Greetings, folks. Welcome. A t-distribution looks a heck of a lot like a standard normal distribution in that they both have a center of 0. They're both symmetric, bell-shaped, and single-peaked. But the t-distribution is different than the standard normal in that the t-distribution looks different depending on the degrees of freedom. Here's an example of a t-distribution with 25 degrees of freedom. Again, it's symmetric, single-peaked, bell-shaped, and it has a center of 0. We use a t-distribution table to find the area under the distribution, specifically in the upper tail. So here's a t-distribution table. The first column shows degrees of freedom, so 1, 2, 3, 4, etc. Across the top row, you have values like 0.2, 0.1, 0.05, and that would be the area under the curve in the upper tail, or the right tail. Fortunately, we can't show the whole t-distribution table on the screen. The print would just be too small. But here's a continuation of that first table. So here you see from 11 to 20 degrees of freedom. Here you see from 21 to 30 degrees of freedom. In a standard econometric statistics textbook, they would likely have a t-distribution table that might show between 1 and maybe 100 degrees of freedom, and then maybe it might jump up to 200 or 250, etc. So you don't need to show every single value for degrees of freedom, but it's nice to have as much detail as you can. Let's answer a few questions using the t-distribution. Suppose you have 25 degrees of freedom. What value of t corresponds with the top 2.5% of the distribution? It's always useful to draw out the distribution first. So here's a t-distribution with 25 degrees of freedom. We don't know the exact point that corresponds with 2.5% of the distribution, so I just kind of put a line where I think that might look, and I write 2.5%. But of course, under the line, I put question marks because I don't know yet the value of t that corresponds with that top 2.5% of the curve. Then I go to the t-distribution table, and I focus on the row that has 25 degrees of freedom. I go over to the column that's headed by 0.025, because that tells us it's the upper 2.5% of the distribution. And we see the value is 2.060. So now you can go back in and you can take those question marks and replace them with 2.060. To answer the question of what's the value of t that corresponds with the top 2.5%, if you have 25 degrees of freedom, the answer is 2.060. Here's another question. Let's say you have 50 degrees of freedom. What value of t corresponds with the bottom 10% of the distribution? So let's draw out a t-distribution. So it's a single-peaked, symmetric, bell-shaped curve. I always like to put a 0 in the middle to remind you that the center of a t-distribution is 0. I kind of did a freehand here, what would look like it would be the bottom 10% of the distribution. And then I put question marks there. So I know at a minimum the value of t will be negative because values to the left of 0 are negative. Here's a t-distribution table. You want to go down to the row that has 50 degrees of freedom. You go over to the column that's headed by 0.1 because that's 10% of the tail. You see a value of 1.299. Of course, that's for the upper tail of the distribution. So if you want the lower tail of the distribution, you have to put a negative in front of it. So here we've gone in and we took what was once question marks and we've replaced it with the t value. So it's minus 1.299. So to answer the question of what value of t corresponds with the bottom 10% of the distribution with 50 degrees of freedom, it's minus 1.299. Here's another question. With 25 degrees of freedom, what percentage of the distribution has a t-score of 1.316 or higher? So let's draw the t-distribution with 25 degrees of freedom. Now we know the t-score, so we'll put a line in there, and we'll put in the t-score of 1.316. What we don't know now is the area under the distribution that is at 1.316 or higher, or that right tail. So to find that, we go to the t-distribution table. Let's go down to the row that shows 25 degrees of freedom, and let's go across that row and see if we can find the value of 1.316. Well, the first value is 0.856. The next value is 1.316. So bingo, we found it, and that corresponds with 10% in the upper tail. So to answer the question of what percentage of the distribution has a t-score of 1.316 or higher with 25 degrees of freedom, it's 10%. So here's your final exam. This is the hardest question we've looked at so far. It says, with 50 degrees of freedom, what percentage of the distribution has a t-score of minus 1.6 or lower? We'll start by drawing a t-distribution. So you have a curve that's symmetric, single-peaked, and bell-shaped. You put the 0 in the center of the curve, so you know you're on the left side of the distribution. So you can put in a minus 1.6, but of course you don't know the area under the curve to the left of that. So let's go to the t-table. We'll start, of course, with 50 degrees of freedom, so we go down to that row, and we see the first value is 0.849. We see the second value is 1.299. The third value is 1.676. But unfortunately, we couldn't find a value of 1.6, which is the value that we're looking for. So does that mean our t-table is broken? No, it just means that a t-table can't show every conceivable value, because if it did, it would just take pages and pages and pages and pages. So let's draw that on our t-distribution. So we learned that a t-value of 1.299 corresponds with 10% of the tail with 50 degrees of freedom. Since we're on the left tail, that's a negative 1.299. We learned that the value of 1.676 corresponds with 5% in the tail. Again, since we're on the left side of the distribution, we put in a negative value. So we've got that minus 1.6 drawn in. So really all we can say is that a t-score of minus 1.6, if you have 50 degrees of freedom, corresponds to anywhere between 5 and 10% of the bottom tail. We don't know the exact value here, we just know it's a value between 5 and 10%. So to answer the question, what percentage of the distribution has a t-score of minus 1.6 or lower with 50 degrees of freedom? The answer is between 5 and 10%.